Oh, all right. Well, we got a good crowd. All right. Well, thanks everybody. So the news for this week is that we decided on a day for the Western Conference. We were not able to get a venue, so we're going to do a 1 day Zoom on 21 March. And so we're looking for papers or presentations that you could send. Ken Sanders or Ken Redcap is running it, but if you send it to me, I'll forward it to him. And that's about it. And Merry Christmas and Happy holidays to everybody. This is the last Zoom for the year. Drake's Australia is not going to be running theirs on Friday. So this will be the last time we'll meet for the year. And don't forget to, if you haven't re-signed up your membership at the beginning of January, anybody who is not re-upped will be taken off the email list, and we'll have to just, as soon as you get back, go back to the store and pay $20 for the year. You'll get back on. Then you get all the notices again. Okay, Ted, you got anything going on?
No, I keep tweaking along on software, making slow advances. Rick with DSES is making great progress, looking at the sky at 1420. I'll let him talk about that. Nothing from me. We want to go around to all those Eastern folks first.
Sure. Let's see. I see Eduard.
Hello, hello. Can you hear me?
Yep. Go ahead.
Good. Yeah, I've been very busy with all sorts of observations and projects and stuff. So I've prepared a short presentation. So I'll share that if that's okay.
Absolutely.
Yeah. Okay, there we go. Now I put it in presentation mode. Hello. Yes, there we go.
All right. Here we go.
All right, there we go. Yeah, so first of all, so back in November and early first week of December, I did a bunch of observations with my 3 meter dish. So this is a dish that is not permanently set up in my backyard, as some of you may already know. So this is a modular dish. It consists of 4 segments around a central hub. And usually these parts are just stored in a shed, but when I have some couple weeks of relatively stable weather and I want to do some observations, I just set it up in the backyard and then afterwards I tear it all down and put it back in the shed. So back in November, I had this dish up and running and I collected a whole bunch of drift scans at 1420 megahertz, mainly of the Andromeda Galaxy, Messier 31. So yeah, the goal of this observation project was mainly to do a mapping of the galaxy. So I was reading through the work of Jean-Jacques Mentoux, F1EHN, and he did a lot of pioneering work on the detection of external galaxies at 1420 megahertz. And one of the things that he managed to do with his 3 meter dish is that he could actually, at least to some degree, resolve the Andromeda Galaxy. So the Andromeda Galaxy is around 4 degrees across, and the half power beam width of a 3 meter dish is about 5 degrees. So you might expect that it's not possible to resolve the Andromeda Galaxy with a 3 meter dish, but the trick is that the sensitivity of the beam is not uniform. It's just maximum at the very center, and then it gradually drops off towards the edges, and at 2.5 degrees away from the center, so at the half power radius, you are at half power. So if you point the dish at one end of the galaxy, you'll see a slightly different spectrum than when you point it at another end of the galaxy. And Jean-Jacques did an excellent mapping of Messier 31, and he was just about able to resolve it, at least to some extent. And I wanted to see if this was also possible to do with a stationary dish, just using only scan observations, because Jean-Jacques had a tracking mount and I don't. I'm doing all my observations in scan mode. So this is an ongoing project. I'm still working on the data processing, or at least pretty much done by now. I just made my first map today, but yeah, I'm not going to show it everything today because it really requires some explanation, and I didn't really have time to prepare anything for today to show. So I'll save that for another time. In the meantime, I did make a new video for my channel about the Andromeda Galaxy, and just uploaded that last week, and that has been doing really quite well. So really quite a surprise how much interest there is actually in radio astronomy. So the second thing I did with the 3-meter dish is a detection of another galaxy called IC 342. So this is a more difficult and more distant galaxy than Messier 31. So Messier 31, the Andromeda Galaxy, is about 2.5 million light years away, still part of our local group of galaxies. And IC 342 is at a much larger distance of about 11 million light years. So that's no longer part of our local group. It has a small redshift, so its spectrum mostly overlaps with that of the hydrogen in the Milky Way, and this makes it quite difficult to detect. So we can only really see the most redshifted part of this galaxy spectrum at around 50 to around 130 kilometers per second. And my earlier attempts at detecting this galaxy that was back in February of this year. That was not very successful because I had a lot of problems with interference in the direction towards the north, where I had to point a dish for these observations because this galaxy is located at a very northern declination. Well, in the first week of December, I did a new series of drift scans, 4 drift scans, and I had much less problems with RFI. So you can see the result here. So this is the average result of 4 drift scans, and you can see that the profile, the hydrogen profile, almost perfectly matches up with the gray line, which is the simulation from the lab survey site. So the small hump at around 100 kilometers per second, that's actually the hydrogen line from this galaxy. So I was quite pleased with this result. So I've also been working with the 1-meter dish quite a bit after I backed up the 3-meter again. So I've been doing a whole bunch of observations of star forming regions at 22.2 gigahertz. So looking for water masers. So these water masers mainly occur in star forming regions, and I have observed a bunch of them already in the past. And what I wanted to do is to re-observe just a bunch of sources so I could check for their variability and stuff. And I've also been particularly interested in whatever is happening in one of these regions, Westerhout 49. I'll cover that in a bit more detail later on. So I'm not going to tell you about all the observations because it's not that interesting and would take a lot of time. But I'm just going to show you a few highlights. So this was from Westerhout 44. So this is a star forming region that I have only observed a couple times back in 2023. And I only detected it, I only had a marginal detection of it. It was very weak. And I just re-observed it last week. And as you can see, there are some nice peaks in the spectrum, especially on the 17th of December. You can see a couple of features around 55 to plus 60 kilometers per second. And this matches up quite well with what I was able to find in the Maser database, MaserDB. So as you can see here on the right, there's there I plotted all the 3 observations that I did from 16th to 18th of December. And you can see that they vary quite a bit. And this is probably not from the variability of the source itself, because, well, masers can vary rapidly, but usually not that rapidly from day to day. And you can also see that all the features in the spectrum are like all the features in the spectrum are equally brighter or less bright, depending on the day. So I think what's going on here is that there's just some variation in the detected relative power level, depending on the pointing of the dish. So remember that we are at these very short wavelengths. Even the beam width of a 1 meter dish is only about 1 degree. So if you're off in pointing by a quarter of a degree, you are already going to notice that. And the other factor that could be important here is what's happening in the atmosphere. So at 22 gigahertz, you can no longer completely ignore the atmosphere. It's actually absorbs some of the incoming radio waves and also emits some noise of its own, some thermal noise. And yeah, clouds can also probably have some scatter effects to some degree as well. So depending on the clouds and the amount of moisture in the atmosphere, that can also cause some variations in the detected level of the maser. So it's when doing these observations, it can really pay off to try to reobserve the same source a couple times, because it's not always going to be as successful. So another thing that I've been doing is doing regular observations of one particular source, Westerhout 49. I've been trying to do observations at least once every 1 or 2 months since I started observing water masers back in 2022. And Westerhout 49 is a star-forming region at a distance of about 36,000 light years, so it's quite far away actually, but it hosts some of the most powerful water masers in the entire galaxy. And they're actually so bright that you can detect them quite easily, even with a 1 meter dish. So I've been observing this source for quite some time to look for variability. So what I'm trying to do here is that I'm trying to look for changes in the spectrum. I'm not so much looking for changes in the level of the features or the intensity, because first of all, I have no way to actually accurately calibrate the vertical scale of my spectra. And the second problem is, of course, as I already mentioned, that things like pointing variations and variations in the atmospheric conditions can also cause changes in the apparent intensity of these masers. So back in November, I noticed that the feature at 6.9 kilometers per second was starting to increase with respect to many of the other features in the spectrum, which seem to be mostly stable. And this was also confirmed by Wolfgang at the Astronomy Observatory. So Wolfgang also presented some new results on the last RTOP, and according to their most recent observations on December 3rd, the brightness of the 6.9 kilometers per second feature had decreased again with respect to their earlier observations, and also when you compare it to the other features in the spectrum. And Wolfgang's reasoning was that this was actually a real drop in the intensity, because he pointed out that the other features in the spectrum were still staying at the same level. And if this was just caused by like random pointing errors and that sort of problem, then you would expect that all the features in the spectrum would be would increase or decrease by the same amount. And that's not what we're seeing here. So I also reobserved this maser on December 11th, and as you can see, it seems to be still brightening. So yeah, seems to be some quite intense variability going on there, even on a scale of a couple days to about a week. So see also the upcoming observation reports by Wolfgang and by me in the next Sarah journal. So that will be out soon as well. Anyway, that was it for today. Are there any questions?
Eduard, This is Chet Mitchell. What's your integration time for W49?
Oh, sorry, I forgot to mention. It's about an hour.
Okay. All right. Thank you.
All right, any other questions for Edward? All right, great work. Thank
Thanks.
you. Anybody else have a presentation they would like to present today? I don't hear anybody, so I'm going to go down the list. Bob.
Okay, I'm busily working away on my projects here. I reviewed what I'm working on last time, so I won't go through that necessarily today. But I've sent out my PC boards to be fabricated, and I'm going to get those back on Tuesday. And I still haven't posted the stuff on GitHub, but I hope to do that, and I'll post a note in the forum when I get that done. And collecting a list of all the parts that I need to order, and I'm about to release that. I've got a lot of things on hand here from previous projects, but I'm real close to Mauser, so I get 1 or 2 day turnaround usually. So I'll probably be building some test boards up over the holidays and see how things work out. And that's all I've got for today.
All right, any questions for Bob? So, Bob, remind us what the boards are going to do.
Okay, I have a board that it's basically a preamplifier and a filter and a switch to switch between a 50 ohm resistor and the input antenna. And I also have a board that I call a control board that provides power to this board. It has a low noise power supply on it. And that board also has a relay on it so that it can be used by itself if you're using a NOALAC type device that has that contact on it that just needs to be shorted. And this is something that Ted put me on to, so it would satisfy that need. And then another board that would work with a Raspberry Pi, either a Zero or a Raspberry Pi 4, that will switch a voltage level, say 6 volts to 7 volts. It would be fed down your coax going out to your radio to provide power to operate the remote LNA and make the transition between the 50 ohm resistor and your antenna. And one other little board that's, I call it the DC injector, that would just have 2 SMA connectors on it and a place to connect that DC power that you're going to feed down the line.
All right, great stuff. Okay, thanks. Conrad Cardano.
Hi. Well, about 2 weeks ago, I got my scope in a box. So I've assembled it, read all the instructions. It saw first light yesterday, and I had some problems with it. No surprise. And then I realized what my mistakes were. So I'm playing with it today, and I've got it set up. It's recording as we speak, and it's next to my observatory outside, and I've got a remote desktop connection to it. If you let me share my screen, I think I can show you something. Nothing exciting yet.
Go ahead.
All right. Can you see it?
Yes.
Okay. All right. There's nothing exciting here yet because the galactic plane hasn't passed overhead yet. But yesterday this looked like a real mess. I don't know what I had the gain set wrong on one piece of equipment, but I corrected that. And today, I subtracted the background. This looks a lot more normal, and I may actually start getting my bump in the next 30 minutes. So let's hope for the best. And this will be the first of many, I imagine.
All right. Well, let us know if you start getting a signal before the meeting's out, and we'll put you back on.
Oh yeah, maybe I'll discover something, but I don't think so.
No,
But we'll see.
we enjoy first light moments.
Okay.
Okay. And if you still have problems, go to the listserv and ask for help, and people will jump in.
Oh yeah, I just want to lastly say people have been very helpful, and I'm very grateful to the Google group whenever I've posted a question out there. They're a great group of people out there.
Oh yeah, yeah. We only recruit the finest people.
I'm sure.
Okay. Okay. Thanks, Chet Mitchell.
Yeah, I don't have a lot to report. I've decided to work on I'd like to give a presentation at the Eastern Conference in May, a little thing about some history at Green Bank, connected to a particular something that was discovered at Green Bank, which is the Tully-Fisher relation. And so I've just been doing some research and reading old papers and collecting information about that. I hope to have a presentation that I can give at the conference and maybe get a journal article out of it. So that's what I've been working on.
Excellent. Well, send if you've got an idea, send a little note to Marcus Fisher or myself, and we'll stick you on the list.
Okay, I'll do that. Thank you.
No problem. Don Latham.
Nothing to report. Just trying to get over our power outage of about a week. And that's about it.
Is that Montana winter kicking in with the power outages?
Big winds, huge winds. I think we're having these things where the jet stream dips down a little bit and gets into the boundary layer. And it raises local hell of 100-mile-an-hour winds. Very, very localized. But it eats a lot of power lines and trees.
As your the antenna you're showing, is that still standing then?
Yeah, it's good. It didn't hit my house or anything. It was further up on the power line.
Okay. Well,
But
good
we
luck.
made it. I've got a generator, so we made it through.
Great. All right. Thank you. Wendy.
Hello. Nothing happening here.
Okay.
Just enjoying listening to other people. Thank you.
All right. Thanks, Wendy. Karl Spielmann.
Hi, afternoon, everyone. We're progressing along with our scope in the box in my physics class. What we've finally got working was the SDR Sharp on the laptop. It took a little bit. We had a school laptop, so we had to get around some of the, I guess, security protocols that they had to make it work. But we were receiving just basic EFM stations right now. We have to get a better antenna hooked up just to test out the rest of the spectrums, but that's moving along quite well. One question, maybe the members might be able to make a suggestion. I have access to, I think it's a 10 or a 12-foot dish that our local observatory is giving up in place of a larger one. So if anyone has a recommendation for research or activities with a dish that large, be welcome to certainly take a look at them and maybe take that on as well. Otherwise, enjoy the holidays, everybody. Thanks again. Great chat today.
Do you have any ideas about whether it's good for Karl? You're a high school or a grade school or?
Oh, it's high school. I teach. It's a high school physics and science research class. So I've got my physics and the research class working on radio astronomy this year. So that's the reason for the scope in the box. And also we have another detector that we're building. It's the this solar weather. I forget the acronym that they use for it. I think it's the
SIDS.
yes, yeah, the Super SID. We've got that one that we'll be building as well, so we can introduce that into the class. But I have locally, I live out here on Long Island, and we have the Custer Institute, which is a local observatory, optical mostly, and they're giving up their 10-foot dish in place of a larger one that they'll be building. So that's the access that I have now to. They've said I can take it apart and bring it home and set it up in the backyard. So I don't know what that's going to entail, but that's the access that I'll potentially have in the future for any research with something that large. So that's where we're at.
You'll be the pride of your neighborhood.
Yeah, I guess.
Right.
How many trees do I have to put around it to?
Yeah.
No trees. You cut trees down. No.
That's right.
A dish allows so much exploration.
Great.
The immediate one is what you're doing already with 1420 megahertz.
Great.
If you need any ideas or suggestions, as the proud owner of another 10-foot dish, I'd be happy to share my ideas. Sounds very exciting.
Great. Yeah, that'll be probably towards the summer if once I do finally get hold of it. But we want to get the scope in the box working so I can get all the SDR and radio and computer stuff, get a handle on that, and then step up. I guess that's what it's called, to a larger dish. It's like getting a bigger house, but I guess. Thanks, guys.
Yeah,
that's like ham radio. Always want a bigger antenna. Yeah.
And once you have the 3-meter dish and you start really playing with it, then you start wishing, well, man, maybe I kind of want an even larger one.
Now, Karl, the other possibility is that we have the 20-meter that you can use as a member, and that would allow you to do immediate radio astronomy now with a 20-meter dish.
Oh, wow. Okay.
And so if you don't know how to get on that line with that thing, that is a member benefit. So I think that'd be perfect for your class. You can immediately you can do pulsars, you can do masers, you can do hydrogen, you can do everything with a 20-meter dish automatically from your computer.
Would that be in the Google groups? Is there like a discussion of how to actually access that? What's the best way?
If you look at the go to the YouTube channels.
Okay.
And actually go to the Google group too, and then we'll answer you, because Steve Zekas will give you the membership information.
Okay.
And then you will the YouTube videos. We got lots of videos of people using the 20-meter dish and walking through how to do it.
Great. Okay, we'll take a look at that over the holiday. Thanks.
Yeah, I think that'd be perfect for your class, especially if you don't have a current working radio thing. It'll get you started, and then you can go into the ones you got in the classroom.
Great. Thanks.
Okay. Illustrious treasurer Tom. On leave.
Well, I'm at least here. So
yeah, good job.
That's a good thing. I've also gotten some good news about my treatment. My treatment regime is about to be changed in about 6 weeks or so, they've told me. So I can actually see the end of the current regime, and something new might be popping up, like I say, after that. So I'm still here and I'm surviving, and that's about all I can say. It's been quite a challenge, and I'll go up here and you can see there's a lot of stuff missing. But anyhow, you've seen that for a while. Anyhow, I'm here, and I might have gotten some good news. So
great.
I'll leave it at that.
Great, Tom. Excellent word. Excellent news. Okay. Thanks. Merry Christmas to you. Okay. Dennis Hoofnagel.
Yes.
We'll go to Dennis Farr. I'll get to you next.
Okay. Thank you, Rich. Nothing to contribute right now. Enjoying the input from the others. and wishing everyone a great Happy New Year and Christmas festivities too. Thank you very much. See you next year.
All right. Thank you. Okay. Now, Dennis Farr.
All righty. Thank you very much. I appreciate it. Nothing really to add. Processing the memberships as they come in. They're starting to trickle off for the year, but I know we'll start up again soon. So everybody pay attention and pay your dues, and life is good. Merry Christmas.
Thanks. Dennis and I have been watching the mass number of membership renewals come in, and got a little. It takes us about 5 minutes or so each for each membership renewal. But when you get hundreds of them coming in a day, sometimes it gets a little fun. Okay, so
Sorry, can I ask a quick question about membership? It's Mark
yeah.
here. Yeah. I joined in June, so do I have to sign up again now, or is it next June?
Okay, well, that's an excellent question. So part of our problem with accounting, because there's only two of us doing this, is that 2025 paying for 2025 dues gives you 2025, and then paying for 2026 dues gives you 2026. We don't have the ability to go and say you paid in June and you're good for next June. Right?
Okay.
You're good for here 2025 for 20, and then if you pay in December in 2026, you're only good for 2026. All right. So that's just because Dennis and I don't have any bandwidth to do that type of accounting. We got one email program that we're using.
So I better pay then for 2026. Yeah.
Yeah.
Okay. All right.
Sorry.
No problem.
Yeah. It's just if we
understand.
charge $30, I can get an accountant, and then we'd be good. How's that? You guys want to do that? You want to raise the dues to 30, and Dennis and I will get an accountant. We'd love to have an accountant, right, Dennis? So, but meanwhile, with 20, we have to go sort of do it this way.
Well, my current intention, and really this probably isn't the place to bring it up, but my current plan is that through the first quarter of 26, all payments made through the first quarter of 26 will be good till the end of 26. Anything after that will be good through the end of 27. Does that sound acceptable?
Wow. Dennis, you're more generous than I am. Okay. All right. Well, Dennis is in charge of Treasury right now, so whatever he wants, he gets. So
Wow.
He'll put the new policy out when it comes up.
Well, thank you very much.
All right. You just heard it here first. Okay. Mark, you're next. What do you got going on?
Yeah.
You might get a reprieve on your dues here.
Yeah, that'd be nice. Oh God. What's been going on? Quite a lot. I waited about 3 weeks to get a SMA connector to Crocodile Clip because I think his name was Adrian in San Diego. He was at the BAA hydrogen line meeting, and he mentioned that I might not be getting the full supply voltage to the Sawbird through the LMR 400 coax cable, which is powered from the Noelec SDR. Yeah. So I measured it. I checked. So I checked the LMR 400 coax cable. So 10-meter length of that coax cable connected to the Noelec SDR. And I measured 4.522 volts. And when you look at the specification for this Noelec Sawbird, it said, yeah, H1 Sawbird 3.5 to 5.0 volts. So I think my bias T at 4.522 is fine. Does anyone have a comment on that? Adrian's not present.
Oh, Adrian must have felt your presence because you just popped in as soon as you started talking.
Yeah, Adrian just showed up, but is the little LED lighting up on the amplifier?
Yeah.
Well, that's the good sign. It's amazing how low a voltage it will actually run at. I think 3 volts is adequate to make it work. I think the full 5 volts is better. It is maybe important to measure it with the amplifier actually attached, but that requires like 2 bias T's to kind of intercept the voltage. So good luck. It sounds like you're on your way and making
Yeah.
things happen.
I'm confident that the Sawbird is powered correctly. Right, progress concerning these hydrogen line observations with the NOELEC dish. I'm struggling at the moment to try and find a good location. As you know, I'm surrounded by RFI, and I intend to operate this in a kind of garden about half a mile from me. Yeah, what's really worrying me is the NOELEC mesh dish, that dipole, the dipole, it really has to be protected from water. Is that correct? If it got rained on, would that dipole would it be ruined?
My feeling that antenna is intended to be mounted outside in all the weather. The
But people have told me if you get moisture down the coax, you're finished.
Yeah, so cover up the coax. I cover them up with plastic bags and electrical tape, and I figure that's going to last a couple of months anyway.
Right, but
And I also make it so the water can't run down the coax. So I put that plastic bag up high so the water runs off.
I feel like I got to put some kind of protection over the dipole because it will rain will water will definitely get onto that cable. Okay,
You
that's my
need to
problem.
talk to Andrew Thornett, who's been in the same weather, but I think it's intended to be out in the weather.
Well,
Are you speaking
I can
about,
comment on this too. It does say, I think, in the instructions that you're going to get more life out of it if you protect it. But on the other
Yeah,
hand, I think Ted is right. You want to use the thing, so you got to mount it out there outside. So you want to take all the precautions you can. So a plastic
but if I
bag
put
is a good
yeah,
idea.
okay.
Over the feed and everything if you have to keep the rain off, and some just a black electrical tape and change it once every two
Mhm.
months or whatever's needed when it as it deteriorates.
I was just concerned if there's like a plastic bag over the dipole, will there be a sort of accumulation of water on that, and will it mess up the uh, reception?
Yes, that could, and you could also have humidity develop in the bag itself,
That's what I read.
but
Yeah.
over time, it's a maintenance thing, I believe, just to keep it working.
Okay. All right, I'll
That's
sort
my
that out.
thought anyway.
Yeah,
so the
in
black
terms of
So
dipole
Bob, you're suggesting
box,
something of a hat over anything and just let the water run off at least.
what's in the dipole doesn't look particularly susceptible to water until you talk about the actual mating with the coax. And the black box, having opened a couple of them, seemed like it wasn't too terribly sealed. Uh, so if we're talking about the normal dipole feed, I don't think that itself is too sensitive. It's just getting water in your coax would be bad.
Yes, and you can
Yeah.
also get it's material. It's kind of like a clay that you wrap around that joint to try to keep the water out of that coax. You can find that at some electronic distributors.
I think
Yeah,
many of
they
us
call
have
it
not gone to that much trouble.
coax seal. You get them, they're like strips of tape and you just mold it all over your connectors.
Can I just share my screen quickly?
Yeah, go ahead. And by the way, I have mine sitting out in all sorts of weather, and it hasn't. None of this has ever happened. It works great.
Right.
So I think, in fact, every time you put something over that feed, you're just reducing attenuation. So, or you're increasing attenuation. So, just be careful putting too much on.
Sorry, can I just make a comment? So,
Yeah.
Andrew here. Yeah, just to say that I've come to the conclusion that this stuff is just not designed to last forever. And one of the problems is to think that that's what we're going to achieve with these relatively cheap dishes and stuff. Basically, I think we just accept that we're using it, and maybe in a couple of years' time, it'll need replacing.
I don't have very good photos, but yeah, can you see here on this picture? So that's
So it's in a plastic box, which is preventing quite a bit of water from getting in.
Well, I wouldn't trust that.
I think you only have to worry about water if the water cannot drain out. So if you've got some kind of a hole in the plastic that'll allow the water to drain out, then you're good. All right. And because this is all metal, if you've got a good electrical connections to your feed there, because I've opened mine up the exact same way you did. And when I got my feed, the solder connection had broken, so I wasn't getting any signal at all. And I got my solder connection back on, and it works great. So, but I think they're pretty robust, and unless they rust on you, and if you look like you're getting a bunch of water in there, you put a little hole in the bottom so there's some place the water can drain out, and you're good.
Okay.
And I don't think that the coax even you just tighten the coax up, and it should be good just with a tight coax.
Okay.
I think you've got something else going on if you cannot get a signal.
No, I'm not at that stage yet. So
I mean, the average amateur radio aerial doesn't have anything much more than this.
Right.
Unless somebody wants to disagree with me on that.
Right. Can I go on to my next topic?
Yeah.
The next topic is the supersid. After I was under misapprehension that I could just use this magnetic loop antenna to receive these VLF radio waves, and I can, but the MLA I bought, it's got a 60 centimeter loop. It's fine for receiving radio stations, HF or whatever, around the world, but I didn't understand that I could not use the amplifier connected to this 200-meter long copper loop that you have to build for the supersid because of impedance matching and sensitivity to RFI. That's why I decided to purchase the supersid preamp from is it Jonathan Pettingale? So
Right.
I bought the supersid about just over a week ago. The amplifier. Any idea how long it will take to ship?
He's got to build them from scratch once you get them ordered. So it depends on his supply of parts, and we regularly reimburse him for parts. So it may take a couple of weeks depending on where he's at on the parts, ordering parts and stuff like that. So
yeah.
Now the one thing, are you using the supersid software?
Well, my intention, I've downloaded the Steve Burrell GitHub software, and I'm preparing to use it. I tried it out, a sort of dry run without an antenna connection.
You should be able to see, and from your location, I don't know, Andrew, which transmitter do you see on your supersid?
Anthorn. It's one called Anthorn.
You should be able to see that on your spectrum analyzer. And if you can't, you should be turning your antenna until that comes in nice and clear. You got a nice good signal on whatever the transmitter is that you're trying to use.
Yeah, 23.4 kilohertz. If you're having real problems, the UKRAA will sell you a what do you call it? Something that produces a signal. Well, mine's gone completely blank. What do you call them that they produce a signal for you at the right frequency?
A signal generator.
One of them. Yeah, they do one at 23.4 kilohertz.
I know, Andrew. Thank you. I know. I did gen up on that. So I've just got a question about the software. It's on GitHub. It's called supersid.py. It's a Python routine. Does anyone know how you interrupt it? Stop it running?
I'm not familiar with the GitHub version. Have you tried the Stanford download?
Well, no. I'm assuming that's not going to work on this version 3 supersid.
See, all the preamp for supersid is basically a sound card because you're dealing in sound frequencies. So it goes into your audio. Now, I don't know if this other GitHub version goes through your audio channel or not. If it does, it should work.
It does.
Okay, then my guess is the supersid on the Stanford supersid, which is what we are really advocating, processes the sound card.
Yeah.
All right. So that probably will work if you are inputting on a sound card.
Can I just share my screen just a second?
Go ahead, Andrew.
Which might help on this. Not least of all because I've been through the same issues which I think Mark is going through. So this is just my C root drive on my computer here. And I want to point out that I've got here supersid 1.1, 1.12, 1.1, 1.2.2. So these are the Stanford supersid programs, different versions. In addition, you're talking about this other one that's on supersid on GitHub. There's been written by somebody else. I myself had significant problems getting that working. I know other people have thought it was brilliant, but I've stuck with these. Now, the reason I mention the 3 versions is because some people's computers can't run the latest version, and there is a way around it. So if you contact me outside of this meeting, I can look up what I did and we can help you out which one works for you. It was a bit of a hassle trying to get it to work in some cases, but I would agree that the best software to use is at least one of the versions that Stanford have commissioned.
Right.
Yeah, the other advantage of that is that it automatically will upload your results to the Stanford database, and you're able to view it on the Stanford database. This other software, I don't know if it does that or not.
Yeah, the Stanford database, is that down? There was some flood or something in November 24.
Yeah, I saw a note that they said it was down right now, I believe. So it's not from the flood. I think they got it working again for a while, but I heard that they were down and the people are off for the Christmas holidays and not getting it started again.
Right.
Okay, so that might be a problem. But when I was doing I had mine up for 5 years, and it's easy. It produces Excel files, and you can look those Excel files up and analyze them to your heart's content for years. So and then you can upload it later. So yeah. Anyway, wish you luck, and get on the Sarah website or the Sarah Google and let us know how you're doing so we can help you some more and make more recommendations.
Right, will do. Thanks, Rich. Thank you.
Well, yeah, good luck, Mark. And
thank you.
Okay, Andrew.
Wait a minute.
Is that it? Oh.
yeah. Sorry, no, I got a problem. Can you hear me? No.
I can still hear you. Yeah,
Oh, you can hear me. Brilliant. Okay. You can't see me, I presume, or can you see me?
we can see you.
Oh, fantastic. Fantastic, because my screen's playing up. Sorry. So, right. Well, thank you. I won't take very long. The first thing I want to just say is that just to remind people that we do have now a hydrogen line group, which meets once a month, and also a GNU radio group, which meets once a month. For convenience, these are under the auspices of the British Astronomical Association, but don't get carried away with that. More than half the members are SARA members. So it's very much a SARA group as a BAA group. It's just a combined of interested groups. So I know Ted takes part in that, quite a lot, a number of other people. We're slowly working through learning how to use GNU radio. You're not too far behind if you wanted to join us at the next meeting. And the Hydrogen Line group is a great place to come and speak to people at all stages in their experience of mapping the galaxy and demonstrating dark matter. So even people many people there haven't started yet. Some people who have produced excellent maps and all in between. So please do contact me or ask Rich to give you my contact details if you want to find out more on how you can come along to those groups if you're interested. So that's the first thing. The second thing is that we've had some discussion online about making Cantenna. So far, I've been making my Cantenna out of coffee tins, which do work, but I've got it in my head to try and produce a proper one of the right dimensions. So I don't know whether I can see what I'm showing here. Where am I? Can't see myself at all here.
Yeah, I think we can see you. Just go ahead and put it in front. Yeah, we can see that.
Is that, yeah. So I've come up with this one. So following Wolfgang's recommendations, it's a 15 centimeters wide, and it comes as 50 centimeters long. So this is one of these sort of wood burning stove flues, which I had some difficulty getting hold of. So I've got to cut that and start putting some monopoles in the right place and all that sort of thing. And it turned out, again, I'm thankful to Wolfgang for recommending that you can get these caps that fit on the ends, so I don't have to start cutting bits of metal around. But what I don't know, Ted, you might know, or somebody else might know, with these caps, it's got this lip bit here. Does that affect the performance of the Cantenna, and does that change importantly the length from the end of the cap through to where the monopole comes into the Cantenna? That's the important question.
Lift it up a little closer to your face. We can see your face. There you go.
No, that's an interior cap. It's just right.
All right. So even this metal lip is not going to affect anything.
No, not really. It's way smaller than a wavelength. Way smaller.
Brilliant. Thank you very much.
And all you have to do is get some very short self-drilling and tapping screws, not quarter inch, even shorter than that if you can get them, but quarter inch, and just put, say, 8 or 10 or 12 of them around the edge. Now mine, you get zinc coat, or they're zinc coated instead of stainless. I'd rather have stainless, but zinc coated, you can solder it up if you've got a really heavy, my Glory soldering iron will do it. But self-tapping screws, if you put a few around the periphery there, you can always take the back off if you have to mess with your probes too.
Well, I've noticed this has actually got some little metal bits that stick out, so I could push those out a bit and make it really quite fit in very firmly.
Yeah,
give it quite a good connection.
Yeah, you can do that too.
So probably get away without even using any screws. I want to. It's actually, these are stainless steel, these bits I've got here.
Right. The water will get in though. You need to actually, if you seal it up, if you've got a glue gun, the thing to do is to stick it up tight in there and then just run a glue gun around the that lip.
Yep.
And that'll take care of it. Clean it with alcohol before you do the glue gun, because there'll be grease on it. And
Okay.
it won't stick right.
Okay, thank you very much for that advice. Thank you.
No problem.
Brilliant, brilliant. So that was the first one. My second bit is we've had a lot of talk again. Those people who follow the mailing list will know about using coaxial relays, and I do appreciate that coaxial relays as a means of switching in and out a reference frequency may not be the world's best way of doing it, but it happens that in all of this I did actually buy a coaxial relay, so I've been trying to get it to work, and I got some weird results, which I have a reason, by the way, of wanting to do this. And Ted and I have been trying this out just to involve the poor chap in this. He's probably saying, "Don't involve me," but I have one of these USRP B210 Chinese clones, which gives you, I think it's 8 megahertz wide bandwidth, which is quite impressive. But what we've discovered is that the sort of noise floor on that gives you quite a slant with a bit of a sort of mountain effect on the left-hand side, which creates an issue of dominating the signals that comes through when you're picking it up on Easy Radio Astronomy or SDR Sharp. So if we're trying to use an offset frequency, well, so Alex Pettit had suggested that we could take the reference frequency by using a different part of the bandwidth, but the problem is that's comes up as a different gain or level on it, which causes problems. So, or a different intensity, perhaps I should say. So what we're thinking is if I could switch in and out a 50 ohm dummy load, then that would allow me to have a reference sample with a similar response without hydrogen as to the signal itself, without obviously the hydrogen signal involved in it. So I tried to do that, and this is what I'm getting. So I'll just share the screen. I don't know if I've explained that very well, but hopefully you get the general gist of what I'm trying to say anyway. Where are we? Right. So this is a plot out of Easy Radio Astronomy, and I'm not even sure if it shows anything or not really. This is over several days. On the right-hand side, we do seem to have a peak which coincides there at the Crab Nebula crossing the Milky Way. But on the left-hand side, we do have a little bit of a peak. I don't know how great it is. But so it looks as though it probably is collecting sub-signal, but nothing particularly spectacular. If I show you the 191 plot, Ted, where are we?
Yeah, that previous plot just looks like temperature variation during a day.
It does, okay. Well, this is the 191 plot. I don't know if there's any other particular plot that you'd like to see.
That's many, many days, like 12 days.
Mm-hmm.
Okay. I don't see a particular pattern on each vertical line. Sometimes there's a little blip, particularly on Ant B max, the higher red line, and that kind of indicates that your signal is weak, and so it only shows up on the max signal definition. Maybe the signal's just kind of weak for whatever reason. We can talk some more.
Yeah, my next plan at the moment is to take the coaxial relay back out, rather obviously, and put the RTL SDR. But actually, is using the RTL SDR version 4 at the moment. So I think I'm going to put that in without the coaxial relay and use the standard 1423 as a reference sample and just make sure it is actually working without it, just in case that's the issue.
Okay. Can I ask you something?
Yes, go for it, Eduard.
If you go back to the first plot you showed.
Yeah, go for it. Yeah.
So I was wondering, what is this showing? Is this showing like the total power level? So basically, like the total background level of the over the whole passband? Or is this showing only the hydrogen line?
This is showing the hydrogen component of whatever he received. And of course, it's a vertical offset map.
Okay, okay. So
For
it's
data
basically
along that little thin black line, red line, horizontal.
okay. So this is showing the hydrogen line with respect to the background or something like that. So basically, how high the hydrogen line stands above the background.
How much of the power in the hydrogen frequencies compared to the non-hydrogen
Yeah.
frequencies?
Okay. Yeah. Yeah. Okay. So this is not like total power. Okay. Then that's clear. So yeah. Then then it doesn't really look like temperature variation because that wouldn't really affect the hydrogen line all that much.
Andy, let's talk afterwards.
Okay. Okay, thanks guys for all the advice there.
Can I ask a question about your relay? Have you tried a pin diode?
No.
It sounds like that would have zero effect on your signal, and it'd be faster and than a relay.
Yeah, I could. I do actually have one somewhere, so I could try that. That would be a good idea.
You still have insertion loss to worry about.
Yeah, but compared to a relay,
no, the relays have as good as or better than the pin diodes for insertion loss, believe it or not. Those frequencies. The insertion loss for the proper relays is about 0.1 dB. They're pretty good.
Yeah, do you have a proper relay though? That's maybe the question.
That's the other question.
I've got a Tatsu C520D.
Don't know it at all. But the thing is, the little relays that you usually find are good up to 18 gigahertz. So it needs to have the spec. It needs to have the proper spec. If it's made for lower frequencies, it won't work worth the darn. The other thing is, if you're going to use 50 ohms for any reference at all, you got to measure its temperature, because its temperature variation and the relay temperature variation is going to be more than the no elect preamp, which varies very little according to Alex, who's done extensive studying on that preamp. So take a real good look at your specs on the relay and see what its upper frequency is good for. Is it an SMA relay?
It's N type.
Type N. Okay. But it may be for too low a frequency. I don't know. I don't know that particular relay at all by numbers. But the little relays that you get are very small, actually, and usually have an SMA connector in them. And don't forget when you put the load on, is it the one that you just screw directly into the Type N connector, or is there a cable on it?
A little bit of a cable because I wanted to connect.
Well, it's as long as it's stable, it doesn't matter. I mean, as long as it doesn't change too much, but you can't really use it too much for calibration. I think we went through all that stuff at one time, and the consensus was that you can't really do Dickey switching, for example, if there's a big temperature difference between the dark deep sky and the temperature of the load, because it's too big a temperature difference, which is why you need a cooled load. That's a completely different problem, actually. If it's just a reference or a spot to look at, then that's good. But it can, there's the relay. Boy, I don't know.
Looks good to me.
Yeah, it looks like it ought to be all right.
Is there a
I don't think
spec page on that?
I'm just having a look.
Yeah, there it is. Item specs.
Talks at
It's
1 gigahertz.
made for a lot of power. Crosstalk 50 dB
Yeah, yeah.
at 1 gigahertz. See, 300 watts power at, boy, that's a real power hog.
Sound like you're on the edge of your spec.
Yeah, I think so too. I really do. Boy, it's a shame that's so expensive. Um,
Oh, I didn't pay that for it.
okay, that's a good deal. Because I think it's suspicious, Andrew.
Mm-hmm.
Well,
I
let's
think
see what it does. Yeah.
yeah,
Let's talk
you
some
know,
more, Andy.
yeah, if and you might be able to ship it off to somebody that's got some measurement equipment that could actually measure the characteristics.
You got a nano VNA you can plug it into?
Yes, I got nano VNA.
And
Oh, run it through there.
Run it through there.
You betcha. Run it through your nano VNA at 1.4 and see what you get.
Okay. Yeah.
You
I think
betcha.
I think a good first step is going to be to take it out of the system and go back to using the rest of the system without it, and just make sure the system's working without it.
Yes.
And if it suddenly starts working well, that's going to tell me that whatever's going on with the coaxial relay, it's as an alternative to as a way of getting a reference sample, it's not working.
I agree. That's the easiest thing to try, but you also could run it through your nano VNA very quickly.
Well, yeah, so absolutely, I will do.
Yeah.
I will do.
Okay.
What
Yeah, thank you
kind
very
of
much.
50 ohm resistor are you actually using on that?
It's just a standard dummy load, El Cheapo eBay dummy load, or Amazon El Cheapo dummy load. It's actually more accurately, it's part of the kit that comes with the nano VNA.
Ah, it ought to be all right then. I mean, it's
Do you
good
have
enough.
Do you have a temperature probe on the on the resistor, or where we put that on the relay or the resistor? I think on the resistor, right?
Yeah. You need the temperature of the resistor. But, actually you can have some fun if you got a heat gun of some kind. Stick it on there, stick it on the resistor and heat the resistor and see how much change you get. You can't hurt the resistor if you're careful with it. Heat it up by 10 degrees and see if you get any change, get any change in your average output.
All right. Okay.
Sure.
Right. Well, thank you. Thank you again.
Okay, let's go with Rick from DSCS.
Oh, here we go. Okay. Well, we've made some progress with the drift scan experiment, and this is whoops, I hope. Here, this is a live view of the active data collection going on right now at Haswell. We are still doing drift scan at 87.5 degrees elevation because I'm not finished optimizing the system yet. So let's see, but we did manage some improvements. Let's see, here we are. There on the DSCS website under projects drift scan, we have this report from Ted. He did an analysis of a recent set of files I sent him, and we're now getting real results with significant amplitudes this is just a quick snapshot, but you'll see in the lower picture, the green line has significant RF at both sides of the scan where we expect it. We left it at the elevation it's pointing at because we knew there was a strong source there at Cygnus A, and up until now it's been sort of iffy, but I think we're getting good results. And so the next step is I am going to switch the receivers from the AirSpy Duo to the B210. They are both active simultaneously. So theoretically, I should just be able to tell the software, no, use the other receiver. But of course, nothing ever goes that easily. And so I've had other issues to deal with, but that's the next step. And I'll be able to compare the B210 with the AirSpy and decide which receiver I want to use for the full scans. Once that's done, we'll start scanning at various elevation angles in approximately 1 degree increments, because that's about what the band or about what the beam width of the antenna is at that frequency. And so that's the drift scan project. Now, we did take a weekend and installed the new deep space package, which is we're running at 8.5 gigahertz, and everything appeared to go well, but we didn't actually have a good reference source in the sky to look at that was continuously available. So we're going to be doing that again with a ground-based reference source soon in January. We'll put the 8.5 gigahertz receive system up. And if that all goes well, we're going to start pointing it at deep space objects and see if we can detect the presence of like the Voyager satellites. So that's exciting. We also had to take the drift scan feed out for the 1296 EME contest. That went pretty well. I forgot the exact number. There were a couple hundred contacts made, almost all digital, but a few CW and sideband contacts. So we've been keeping very busy this season. Back to you.
It's exciting what you're doing, Rick. This is great. For folks listening in, this is unposted code from for Ezra that we're experimenting and trying to develop. This is for using SOAPy drivers to talk to all kinds of other new SDRs. So if you need it, come talk to me by email.
All right.
Great, Rick.
On the good work, Rick, and your whole team.
Thank you.
Okay. Robert Mead, did we get you yet?
Nope, not yet.
Good.
If I could share, I don't have charts for today, but update you on 3 or so different happenings. Let me know if you can see my screen.
Yep.
Okay, so this is a live view of collection from 5 of the 1.5 meter dishes in the backyard. This one at 0, I believe, is at 100 degrees elevation with reference to 180 degrees south azimuth. And then there are 5-degree steps going through zenith. And the 5th one is off on some other screen somewhere. So this is just using Dispra as a live readout to see that stuff appears to be working. And then my flow graph has, this is interleaved INQ of just kind of a heartbeat on the data coming out of the Kraken SDR. And it's only showing you a time to main trace every so many microseconds or whatever, and it will skip. This will skip a little bit, but this lets me check the kind of most annoying thing that I had to work on in the capture flow graph here. So I've swapped out the default Kraken SDR source. If you read the source code here, there's like 2 or 3 different things wrong with this for this application. First is that it does not zero fill when it goes into calibration mode. It just skips those samples. So if you're trying to record very long periods of time for use in post-capture interferometry processing, you're going to drift in time every time you go through kind of a scenario where it will calibrate. So I rewrote the source so that when it goes into calibration mode, it zero pads based on the timestamps in the actual packets from the Heimdall DAC. And then there was 1 or 2 more not so fun things in here. There's a race condition because they reused the same class level variable for the IQ samples. So this is not public block yet. Would like to get a version of this out for any other folks that are interested. But now we have 0 padding to maintain timing for radio astronomy. I've also implemented in this capture flow graph a bunch of SIGMF metadata format stuff that goes alongside my 4-bit packed IQ files. Last week, I think it was last month now, I open sourced a embedded Python block version of the 4-bit IQ packer unpackers. So that's up on my GitHub under my full name. And then the SIGMF metadata stuff, I had sent an email to Ted recently, hoping to work with him on that, on some integration into converting the 4-bit IQ plus SIGMF meta directly to Ezra spectrum format, not for interferometric processing, just for kind of your traditional Ezra stuff. So I had a script for that, which is using Python multiprocessing to go through like a 200 gigabyte file a day, 16 threads on it or so, read into a queue, let the workers pull off stuff, whatever they want. And that's taking about 15 to 20 minutes for a day's worth of data. It's mostly read speed limited from the disk, less processing limited. And then I have some plots out of a little bit of that processing that are live. So this is one where I was doing the RMS magnitude of the FFT. This is 1 minute frames with no overlap between them, and then kind of just manually tuning the scale on the spectrogram here until you can sort of see the hydrogen line galactic plane crossing repeating once every 24 hours with similar intensities. And then you get the other flavor of it with about that 12-hour-ish kind of separation, because this one is 85 degrees elevation at south pointing. As you can see, I have a lot of kind of RFI at home. So in converting this to spectrogram data and then using Ezra, I very much need to figure out the right arguments to drop some of these bins. And I'm doing a rather high bin count with pretty fast averaging from what I've seen in the rest of the community, not doing 5 minutes and doing 4096 bins here. And I'm told 5-minute averaging with 256 bins across 2 megahertz is more common. So that's pretty much where the called Deep Sky Dish interferometer capture script is at. Not really using it as an interferometer at the moment, trying to get a baseline hydrogen scan of the sky, looking at 5 different elevations at a time with 5-degree spacing. So I also have just a little gallery from the last couple of weeks. This was kind of the first time I was able to run Easy Sky on converted data. And I'm sure Ted is looking at the traces red, and that means something. And I need to very much check which traces are what. But that does look like intensity increase over 1/2 of the galactic plane. And I think I need to drop some bins so the noise reference is right, so I would see more of a difference across the other part there. Those are some more of the kind of outputs of the post-processing script just in spectrograms. And then alignment is something I wanted to share some details about. So aligning the dishes to a very precise 5-degree spacing. 1 a.m. is a great time because no airplanes, and in this case, it was a very cloudy day. This is an inverted image of taking the laser sights on 5 of the dishes and telling my telescope to point, which was already calibrated based on plate solving, point in Altaz coordinates that are 5 degrees apart, spaced along south bearing, and then you manually align that dish to where that laser dot is at effectively infinite focus. Then you do the next one and the next one and the next one. So if you turn them all on and take a long exposure camera shot, you see something like this. You can see they're very uniformly spaced along that line there. And there's that without the inversion. So I actually made, because the clouds give it a cool background, about a minute or so long animation of that, just kind of snapping frames. I know they're probably hard to see the dots in this. You need to adjust the brightness. So that was kind of the first real trial of precise alignment to do a sky scan. It also snowed here, so some of the data you're looking at is from when there is snow, and thus intensities may vary. I was doing a lot with optimizing the feed distance from the 1.5 meter dishes here. I originally had these at 140 millimeters on the mark at the 20 millimeter adapter from the 1-inch PVC. I moved those down to 110 based on experiments and just seeing that my ground noise stopped mattering as much and my hydrogen line SNRs seemed to improve. I think that's because this feed being a dipole and a reflector, kind of like a Yagi, has a little bit lower gain at 1.4 gigahertz than it does at 1.68 gigahertz, because the 140 millimeter distance came from maximizing SNR when receiving GOES 16 weather broadcast. And then there's another project going on in the background, which is working on a CG5 dovetail adapter for the Discovery dishes. So I have this 3D printed part with a, that's an M12 threaded rod adapter to put on counterweights, and a couple photos of that. And you can see this is some rather old testing footage of without a counterweight on one of the Celestron mounts, being able to command the dish to move around in either Altaz or RA Dec coordinates. This isn't super great for satellite tracking because it doesn't like to be told where to go quickly. It wants to be told one thing and then inch into it very precisely, like it were holding an optical instrument. But I think there's some potential here to like try tracking pulsars and see if you might be able to get just a detection with kind of the matched time integration with the spacing and the pulse duration, and kind of doing a blind search for it based on known pulsar database. Just to show you, here's one of the ones with the counterweights attached. I've been able to get this to work on both the 2 Altaz mount types I have that are Celestron products, as well as the AVX RA Dec mount. And then I'll just close with a little bit of a bonus and then some questions on the 20 meter dish. So this dot that's smeared out, stacking stars with RA Dec tracking. This smear is 3i Atlas. Obviously, if I go to integrate stacking on the comet position, I can maybe resolve some of the shape here, though I think that'd be difficult with my 8-inch aperture. But 3i Atlas, plus I think I got satellited, and then this is pointing to roughly where that image was taken, and got a cool diffraction effect there, which might be the aperture related there, or might be a branch in the way. So, any questions on miscellaneous updates?
Robert,
If
this
not,
all
I'll
looks
ask
really
my.
cool. We want to come visit your house. It's kind of like Disneyland for us with all
Yeah.
these dishes. Did you
But
want to
my
stay after the meeting and you and I can chat probably with Andy?
yes, definitely. I also wanted to ask that. So the 20 meter dish, and you sent the link to, or folks in the chat sent the link to get time on that. Has anybody in the club tried to look at the hydroxyl absorption lines with the 20 meter instrument from 3i Atlas?
Oh, no. I don't think so. Not for 3i Atlas. That'd be great.
Okay, I'm just not sure how to reserve time on it, but I think that'd be a great use of that, because the research paper we were talking about a month or two ago, I think they used a 13 meter.
I think Wolfgang already was looking at whether it would be possible to detect it, and with their 25-meter dish at Astropijler, and his conclusion was that it was too weak.
Even with the 20?
Yeah, but I'm not sure.
Oh.
Maybe you can ask Wolfgang.
Okay.
Well, I think you want to just go try it at the 20 meter. Why not? Well, you know how to get on the 20 meter with Steve Zekas getting you an account?
I do not, but I saw the contact email on that page there. I
Right.
guess I can shoot him an email.
Yeah, and then actually tell him what you're thinking of, and he'll help you. He might probably help you aim it, or at least point it.
Okay.
You just need to know the coordinates. You can put the coordinates in. They may or may not have it in their database as a because they have a lot of the stuff in the database. You could just request it, and it'll point to it automatically. But if you don't, you should probably have the coordinates for it. And
Yeah,
then,
this one's a little weird because it is moving in RA Dec, so
right.
I don't know how they do custom sources that don't have fixed sky coordinates.
Well, you could put
If you're joining, so if you're
it.
joining Ted and I afterwards, Rob, then I have the account details and we can have a go.
Okay, cool.
Yeah, that'd be fun.
I think that's a valid point, though. I think the the 20 meters designed only for tracking fixed celestial objects. So I'm not sure what the movement of the comet will do in terms of being able to track it.
Yeah, we might be able to do just a drift scan through it.
You can go down
any
to
point
1
quick.
second. So if 1 second's too long, that's a problem. But we can certainly do it for a second.
How much does it move actually? Like, if it only moves like a tiny fraction of the beam width, it's not an issue.
That image I was showing you was about 15 minutes of stacking. I didn't exactly plate solve it, but there's plenty of 3i Atlas trackers you can go look at to get an idea of the
Well, then
motion.
I think that I don't know, like, what is the frame of the image, like how large it is. Maybe it's 1.5 degrees. I don't know, something like that.
0.6 by 0.6 ish.
Okay, so the half power beam width of that 20-meter dish is also around 0.6 degrees. It's 1600 megahertz. So I don't think that the movement of the comet is really going to be an issue.
Okay.
I don't think so.
Well, that sounds like good news. We can just point to the same kind of accuracy as my telescope, and it'll be in the beam.
Yeah.
It'd be fun. Let us know what you get.
A
All right.
silly question. Why Kraken? I've heard of it, but I'm not familiar with it at all.
Kraken provides time and phase coherent IQ samples, so you can do interferometry in baseband. So the purpose was to be able to try interferometric imaging of hydrogen line sources, though that processing is more complicated than what goes on with Ezra, and I have yet to attempt that, which is why I'm trying to save as much 4-bit IQ as possible so I can go back and figure it out later.
Thank you.
Well, it also does 5 channels simultaneously, right? So that's the other advantage.
Yes, you could duplicate what I'm doing for the Skyscan spectral analysis only with just 5 RTL SDRs, though, which is going to cut your cost for receivers by like a fifth relative to the Kraken. So unless you're doing interferometry, I'm not sure that the Kraken is worth the cost difference. Or
Okay.
phased array beamforming like you were trying to do, Rich.
Yeah, which did not succeed, by the way. So,
well, you could also use it. You could also use it to increase your bandwidth, right? You could use multiple receivers or have multiple bands that you're looking at with one dish.
Yes, you could do that if you wanted to put a splitter on there, and then they could tune separately. It's just you're paying for the FPGAs and the Heimdall DAC stuff that you don't need when you could just hook up 5 non-coherent RTL SDRs. Or if you need higher bandwidth, I think an AirSpy Mini is like Eduard had used when looking at Andromeda. That's a pretty good bang for your buck, especially during the Christmas sales.
All right, great. Robert, let us know how you do. And if you have any issues with getting on the 20 meter, let me know. Okay, Adrian, I think you're last.
Oh boy. Uh, I don't really have much of anything, but I would like to make a comment about the earlier discussion on the Sawbird and the voltage to drive it. And so if you look at the MMIC specs for a lot of the MMICs that are rated at the 5-volt optimal gain, now the Sawbird has theoretically something like close to 30 to maybe as high as 40 dBs of total gain with the dual MMICs that it has. So if you do look at the spec sheets on a lot of those MMICs, if you drop the voltage from 5 to 4.5 volts, you could lose as much as a significant fraction of a dB, like maybe 0.7 or 0.8 dBs. And of course, combined between the two MMICs, the problem is that the bias point for those MMICs is probably just a resistor type network. And so you're not going to get a stable bias point from just the input voltage. So combined between the two MMICs, if you drop from 5 to 4.5 volts, you might lose as much as possibly as high as a couple of dBs. Now, in light of the total gain of the whole Sawbird at 30 or 40 dBs total gain, that might not sound like much, and it might not amount to much. So my actually comment was that that you might lose a couple of dBs, and so for optimal gain on the Sawbird, you should really run it at 5 volts. Now, Ted mentioned, well, if you see the LED light, you see the power's getting to it, but red LEDs light up at around 1.4 to 1.5 volts. So even with just a dropping current resistor on it, you're going to get that LED light. So you might not see the difference in intensity of the LED between 4.5 and 5 volts in terms of the amount of current that's going to increase at 5 volts. So I agree, it might not be significant, but my comment actually was just that if you want the optimal gain from the Sawbird, you really should try for the 5 volts input to it. And so my suggestion was basically to use a power supply that maybe has a slightly higher voltage, maybe 6 or 7 volts. And if you designed a very simple voltage regulator at the input to the Sawbird that would drop it down to exactly the 5 volts. And there's a lot of very accurate low dropout voltage regulators that function at 5 volts. And then so you could actually bias it exactly at the maximum efficiency for maximum gain out of the LNA. So that was basically my comment. So I didn't say it would not work. I just said that for optimal gain, you really should run it at the full 5 volts, which is what the MMICs on the LNA amplifier are rated for. So anyway, I just wanted to make that comment in order to maybe clarify the point that was being discussed earlier by I forget who it was. Was it Mark? Was that you that we were discussing the Sawbird?
Yes, it was. You mentioned it.
Okay.
BAA.
So anyway, yeah. Okay. So that was my only point. So if you really want the maximum full gain out of it, yeah, the bias T will run it. I didn't say it wouldn't, but it might not be at exactly the optimal gain if that's what you're shooting for. And so that's basically my comment. And besides that, really the supply that comes out of your bias T from most of these SDRs is actually coming from your computer. And if you look at the USB voltage output from a computer on a scope, it's got a lot of high harmonics from the switching supply that are still rippling around on it. So my other point was, if you build a linear power supply, and that's not going to have any significant ripple out of it, once you have filter capacitors just to smooth out the current frequency of 60 hertz in the U.S. and 50 whatever in the U.S. With the filter capacitors, it's not going to be too high. And then again, by the use of a low dropout voltage regulator, those things are excellent. That's completely getting rid of just about any of the residual ripple out of the voltage on the supply. So I'm not sure how much of those high frequency switching sort of supply noise is going to contribute to any potential noise out of the LNA. But again, just in terms of optimizing the maximum signal and purity out of it, I would suggest a linear power supply and running it out of a bias T to it, as I suggested, and not necessarily just the voltage coming through from the SDR bias T. Anyway, those are just the points that I had discussed earlier, I think, with Mark, and so those are my comments on that. So anyway, that's pretty much all I have to say.
Hey, Adrian, so I actually bypassed the whole bias T issue by taking a power cord out to the dish and putting and hooking directly into the USB with an adapter from a power cord. So not even using a bias T. Is that would that solve all these issues by having, I mean, linear, all that kind of stuff? It seemed like that was very complicated because of the bias T.
Well, yeah, it is more complicated. I mean, it's a lot simpler to just run it directly out of the bias T coming out of your SDR. But my point is that the voltage coming through the SDR, which is derived from your USB voltage output, which is from the power supply in your laptop or your computer, it does have some significant amount of ripple in it from the switching supply, which is it's in all the computers. And the only reason that switching supplies are used is because they're so much more efficient. It can regulate the voltage pretty close without having to drop any voltage across a voltage regulator. And with a linear supply, the efficiency is lost because if you have excess voltage, which you need in order for the regulator to work, you have to lose that excess voltage into something, and it goes into heat into the voltage regulator. Again, you want to use a low dropout. So low dropout voltage regulators basically require less overhead on the voltage in order to have the regulation at the whatever voltage you're rated at. In this case, you want the 5-volt voltage regulators. And kind of a clunky old regulator that's used that can handle, gosh, maybe up as much as an amp is the 7805. There's a whole series of 7-8 voltage regulators that are for 12 volts, 18 volts, 24 volts. So the two last digits are for the reference of the voltage that you need. So if you use, for example, a 7805 voltage regulator, you probably need an overhead of maybe at least a couple of volts. So you probably need something like at least 7 or 8 volts in order for it to effectively regulate at 5 volts. So if you use other class voltage regulators, are slightly better at the overhead that they require, and so they're called low dropout. And the low dropout just means that if you drop below that overhead, that voltage regulator is not going to be working. It's not going to be giving you the output that's supposed to be rated at. So it's basically that overhead that you need to look at depending on the voltage regulator that you're using. So again, low dropout voltage regulators, you might only need something like just maybe like 1.5 volts higher than the actual voltage that it's going to be regulating at. So you might only need something like 6.5 or 7 volts actually coming to it. And so the circuitry for those are really simple. You need an input filter capacitor and an output filter capacitor on either side of the voltage regulator. So it's really a 3-component circuit. It's not very complicated. And the output from that would then give you that very nice, smooth DC voltage input into the LNA without any switching power supply ripple. So anyway, that was my comment.
All right. Well, you got anything else?
No, that's it. Thanks.
All right. Any other questions for Adrian? All right. Any other presentations or comments? All right. You guys have a great New Year's and Christmas, and take care of all your radio astronomy projects while you got all this free time. Yeah. All right. See everybody next year. Thanks.
Yeah. Happy Christmas, everybody.
Yeah. Happy Christmas. Bye.
And,
Merry Christmas, all.
Next year, Mark, you can tell us how you've had massive success over Christmas. And